Okay, so today we're going to talk about measures of dispersion in statistics. So the last one was central tendency, so now dispersion is like analyzing how much the data is spread out. Okay, so we have two sets of data, group A and group B. I've listed all the pieces of data in each. So I have already done these for you. We're going to calculate the mean and median, mode, and the mid-range from the first lesson. So the mean is you add them all up and divide, and we have 10 items, so add up and divide, and you're going to get 71.5. If we add all of these up and divide by 10, we also get 71.5. Okay, median is the one right in the middle. Okay, so we have to go 1, 2, 3, 4, 5. So the median would be 72. 1, 2, 3, 4, 5. So there is the median, and 72 is also the average of those. Okay, most often occurring for the mode. In here, 77 appears the most times. In this group, 77 also appears. Okay, and the mid-range would be 77 subtract 56, and average, which comes to 71. 100 minus 42, and average that, or sorry, plus, and that also comes out to 71. So as you can see, these two pieces of data have the exact same measures of central tendency. So today we're going to talk about, obviously these pieces of data are different than each other, but how can you compare if they have the same results for the measures of central tendency? So the range is something to show you how more spread out one is than the other. Okay, so the first one, 77 is the high minus the low. So that means that one is spread out over a span of 10 numbers. And this one is 100 minus 42. So this one spreads out over 58. So you can see that in group A, the data is closer together, and B is more spread out. Okay? Okay, now let's just look at these two groups, group A and group B, the numbers. Okay? So kind of comparable, but you can see that they're different, right? So the measures of central tendency are going to be limited. So the measures of central tendency, they don't give us a complete picture. So we learned that last time. It gives us an idea about the data, but not always everything. And then we learned that the range also helps us understand the data. So A has a range of 20 minus 1, which is 19. And B has a range of 18 minus 2, which is 16. So also, that doesn't really give us that much more of an idea about the data. So we're going to also talk about standard deviation. Okay, so standard deviation is how far away the scores are from the mean. This helps us understand more, I have an idea if the data is close to the mean or if it's really spread out. So let's say that you had one set of data that has a mean of 75 and another with a mean of 75. The first one had a standard deviation of 5, and the second one had a standard deviation of 12. Okay, this one would have the data spread out way more. Does that make sense? Okay, so what does that look like? So I'm going to use that exact same numbers. So if I have a mean of 75, okay, one standard deviation away would be 80 on that side and 70 on that side. So that means that 68% of the data falls between 70 and 80. Another standard deviation away, so 85 and 65. This would be 95% of your data falls between those two numbers. And then if we go another one, the whole 3 standard deviations away, 99.7% of your data is within that span. Okay, versus our other set here, we had a 12 standard deviation. So 75 plus 12 is 87. And on the other side, we have 63. So you can see that 68% of your data falls within a bigger range. And if we keep going in that regard, we have 99, 111, 51, and 39. Okay, so you can see that 99.9% of the data falls between 39 and 111 compared to this one, where they fell within a closer span of numbers. Okay, standard deviation, to calculate it, is a long process. Okay, I'm going to do one by hand. More than not, we use devices. So you can see in here, if I have this data in here, that I can find programs that calculate standard deviation and mean for me. Okay, so there's computers that will do it for you, but we're going to learn how to do it by hand. Okay, so I'm going to start with something simple. Here's my scores. 2, 3, 5, 6, 9, 17. Okay, first of all, we need to find the mean. So we know how to do that. We add them all up, which is 42, divided by 6 numbers. So the mean is 7. Okay, so we're going to create a chart. The score so we have the scores that were given. Okay, so we're going to go the score, subtract the mean. So 2 minus 7 is -5, -4, -2, -1. 9 minus 7 is +2, 10. Okay, so that's the score, subtract the mean. Now we're going to take that value and we're going to square it. So 25, 16, 4, 1, 4, and 100. Okay, so now the next step is that we have to add up that. So this whole column here adds up to 150. Okay, so let's plug this into the formula. We're going to have the standard deviation is equal to the square root of the summation of x minus x, the mean squared, divided by n minus 1. Okay, so we have the summation of our scores subtract our mean squared, so that totaled 150, divided by n minus 1, so we had 6 scores, so we have 30 inside there, and when we square root it, we get 5.48. Okay, so this tells us that remember when I talked about the curve here, if I have a score of 7, okay, that's 12.48, and on the other side we have 1.52. So 68% of our numbers will fall in between 1.52 and 12.48. Okay, that gives us an idea. And another word you might see is variance. And on your formula sheet, it gives you is just your standard deviation squared. So in our case, when we look back to squaring that, we get back to that number, so that our variance is 30, just telling us another number of how far data is spread out.